Dear students, welcome to the problem solving session on discrete random variable part 1. In the previous video, we see the definition of discrete random variable and we see all the possible types of questions can be asked in terms of discrete random variable. Now in this video, we are going to practice problems on discrete random variable. Random variable X has the following probability distribution. First, we have to determine the value of A, probability of X less than 3, greater than or equal to 3, probability of X lies between 0 to 2. Similarly, X lies between 0 to 3, including 0 and 3. Finally, we have to find the distribution function of X. First, we have to find the value of A. To determine the value of A, we know that sum of probability is always equal to 1. If you add all the probabilities, it is going to be 1. Now, when you adding this, we will be getting 81 A is equal to 1. Therefore, A is equal to 1 by 81. Next, whenever we saw discrete random variable problem, if they ask you to find distribution function or cumulative distribution function or simply distribution, first try to complete this because from this we can easily get the other values. So after finding A, I am going to find the distribution function for the given problem. The cumulative distribution function for the given problem is capital F of X, that is probability of capital X less than or equal to small x. For this, you just make a table with 4 rows. The first row is given X, the second one is probability of X, the third and fourth row you can write it as capital F of X. In case of discrete random variable, we don't want to use the formula and write one by one in a big list. Instead of this, make a table and we can simply fill the table in a easiest way. Now, F of 0, it is going to be P of X less than or equal to 0. Since my problem is starting at 0, this is nothing but probability of X equal to 0. At X equal to 0, probability is A. So this value is going to be A. Next, to find F of 1, just add this 2. A plus 3A is going to be 4A. To find F of 2, add this 2. 4A plus 5A is going to be 9A. Next one, 9 plus 7, 16A. Next one, 16 plus 9, 25A. So just keep on adding the cross and write the answer in the down. Similarly, 36 plus 13, 49A, and 49 plus 15, 64A, 64 plus 17, 81A. And now we can check at the end. Always the last value should be 1. We have 81A and we know that A value is 1 by 81. So we get 1. If your last value is 1, then your data is correct. Otherwise, you have to check where you did the error. So the table gets over. The information which I am giving below the table, this is for your reference. In exam point of view, you don't need to write all these things. Just you have to fill the table. Next, we have to substitute the value of A. So it is going to be 1 by 81, 4 by 81, 9 by 81, etc. Finally, we have 81 by 81, that is 1. And you have to write the wordings from the table. Capital F of X values are the cumulative probabilities. So CDF get over. Next, we are going to find probability of X less than 3. So X less than 3 means up to 2. So probability of X equal to 0, X equal to 1 and X equal to 2 we have to find. It is nothing but A plus 3A plus 5A. So we have 9A. So my final answer is 9 by 81. You can stop here. You need not to simplify further. Next, we are going to solve P of X less than 3 using CDF. According to the formula of CDF, F of X is equal to probability of X less than or equal to X. So, probability of X less than 3 means it is nothing but probability of X less than or equal to 2. According to the CDF table, up to 2 is 9A. So I can directly write this as 9A. My answer is 9 by 81. So either you can use this method or the classical method which we know. Both are correct. Whichever is easy for you, you can take into an account and solve accordingly. Next, P of X greater than or equal to 3. So if you want to solve classically, P of X greater than or equal to 3, we have to take the probabilities from 3 to 8 and we have to add everything and then finally we have to substitute A. Therefore, my solution is 72 by 81. So it is better always to substitute the a value at the end to avoid calculation errors. Now, this p of x greater than or equal to 3 can be solved by complement method also. We know that probability of x greater than or equal to 3 is equal to 1 minus probability of x less than 3. If it is less than 3, then it is nothing but probability of x equal to 0, 1 and 2. So I can write this as 1 minus probability of 0 is a, probability of 1 is 3a, probability of 2 is 5a. So we have 1 minus 9a, that is 1 minus 9 by 81. We get 72 by 81. You can see the typed version. So whichever is easy for you, you can adopt and you can solve in that method. Next, what is the probability of x lies between 0 to 2? We have only one data in between them, that is probability of x equal to 1 is nothing but 3a. We write 3 by 81. Next, probability of x lies between 1 to 3. Here we have less than or equal to. So we have to include 3 as well as 1 and then 2. Probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 will give you the solution, that is 3a plus 5a plus 7a is going to be 15a. So 15 by 81 is my answer. So we have completed this problem, and very important thing what we learned here is always try to substitute the constant value at the end of the problem unless otherwise it is not complicated. Here in this problem, everywhere in the probability, the unknown is simply a power 1. So I am just doing as it is. At the end, I am substituting the a value. Suppose if your probability is little complicated like 17a square plus a, it is better to substitute the value and simplify the problem. So we have to change according to the problem. Next, let us see one more problem. Take random variable x whose probability function is given. As usual, we have to find a, some inequalities, CDF. In this problem, in addition, they tell you to find mean, variance of x minus 4 and variance of x minus 4. As usual, find a. We know that sum of the probability is going to be always 1. Add all the probabilities. We find the value is 25a equal to 1. So a equal to 1 by 25. Next, as I said in the earlier problem, whenever there is a CDF in the question, let us first find the cumulative distribution function and then we proceed to the further step. So now we are going to find CDF. So capital F of x is equal to probability of x less than or equal to x. For the first value, we'll get the same one, a, and then f of 1 is a plus 3a. Then 4a plus 5a is 9a, 9a plus 7a is 16a, 16a plus 9a is 25a. And as I said, you have to check the final value. Since a value is 25, 25a is 25 into 1 by 25. That is simply 1. Then our calculations are correct. So we have to write at the end. From the table, we can easily find the CDF. So CDF part gets over. Now we have to substitute the a value in the fourth row. A is 1 by 25. Substituting this value, we can complete the table. Next, we are going to find probability of x greater than or equal to 3. So greater than or equal to 3 means it involves 3 and 4. You can write directly. 7 plus 9, that is 16a. So my answer is 16 by 25. Next, what is the probability of x lies between 0 to 4? In 0 to 4, we have 1, 2, and 3. Therefore, probability of x equal to 1 plus probability of x equal to 2 and probability of x equal to 3 will give the solution, that is 3a plus 5a plus 7a, that is 15a. Therefore, my answer is 15 divided by 25. Always substitute the constant value at the end to avoid calculation error. Next, we have to find the mean. So wherever they ask mean or e of x or mu or expectation, all are going to be the same. And we know the formula for mean. E of x is summation x into probability of x. So just make a column x and probability of x, and we are going to multiply this x into p of x. Also in this problem, we need to find variance of x. The formula for variance of x is e of x square minus e of x whole square. From these three columns, we can find e of x. To find e of x square, we have to square the values of x, and then we have to multiply x square with p of x. To find the mean and variance, better to make a table with 5 columns: x, probability of x into p of x, then x square, finally x square into p of x. Now fill the x and p of x. Just multiply and write the values 0, 3a, 10a. Similarly, next fill the fourth column by squaring x, and then multiply x square with probability of x. At the end, we have to add the total of column 3 and column 5 to get e of x and e of x square. So my expectation is summation x into probability of x, which is nothing but 70a. Next we have to find variance of x. The formula for variance of x is e of x square minus e of x whole square. E of x is 70a, so 70a whole square. E of x square is x square into p of x, that is going to be 230a. So 230a minus 490a square will give you the final solution for the variance. You can use your calculator and see here we have 4900 by 625. If we multiply and divide by 25, then my denominator will become 625. I can easily subtract with the second term. So my final answer is 850 divided by 625. If you want, we can simplify further. This 34 by 25. Next, we are going to find expectation of 3x minus 4. We know that expectation of ax plus b is a into expectation of x plus b. If we have minus, expectation of ax minus b is equal to a into expectation of x minus b. Just now we found e of x is 14 by 5. Therefore, expectation of 3x minus 4 is 3 times 14 by 5 minus 4. Simplifying this, we get 22 by 5. And there is one common mistake students will do. Probability lies between 0 to 1. Your cumulative probabilities lies between 0 to 1. Expectation need not to be lies between 0 to 1. Expectation is a real number. It may be anything, 0 or negative or positive. Hope you understand. Next we have to find variance of 3x minus 4. We know the result, variance of ax plus or minus b is equal to a square into variance of x. So variance of 3x minus 4, it is going to be 3 square into variance of x. 3 square is 9. Just now we found the variance, that is 34 by 25. Simplifying this, we get the answer 306 by 25. Therefore, variance of 3x minus 4 is 306 by 25. In this two problems, we learn how to find CDF, how to tackle inequalities, how to find the mean and variance of the given problem. In the next session, we will see one interesting problem which we have conditional probabilities and how to crack modulus problems.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.